We have been looking at systems of two variables and two equations. We've had a couple different methods of solving those. We could solve them graphically, right? We could graph the two lines and look for where they intersect, but typically that's not the most accurate method. Our preferred methods would be substitution and that addition multiplication type method. Okay? We are shifting today to solving systems that involve three variables. And the general rule is for however many variables you have, you need that many equations. So we are now moving to a system where we have three variables and three equations. We could solve these using substitution. We could solve these using addition multiplication. We're going to go through it with the addition multiplication method, but keep in mind that there is a process we could do using that substitution idea. Okay? So our first step today is just can we verify a solution? So instead of looking for an ordered pair where the two lines intersect, we would now be talking about an ordered triple. Okay, so we're going to look at how can we verify if it's a solution or not, and then we'll start solving some systems. I'm not going to ask you to graph an ordered triple, but I want you to be able to visualize what we're talking about. We are moving from 2 dimensions to 3 dimensions. So it's difficult on a 2-dimensional piece of paper to accurately show a 3-dimensional graph. But what I want you to consider is picture that you've drawn an XY axis on a piece of paper. The Z axis then would be going straight down through the paper. Does that make sense? Perpendicular to that. Okay? So we could take an ordered triple like this 5, -3, -2. We'd have to find 5 going in the positive X direction. We'd have to go -3 in the Y direction, and then we'd have to go down 2. Okay? All right, so the first question asks, is this a solution to the system? For it to be a solution, it has to work in all 3 equations. If you try it in the first equation and it doesn't work, double check your math, make sure you didn't make a mistake. But if it truly doesn't work, you can stop because it has to work in all of them to be able to say it's a solution. So as soon as you get to one where it doesn't work, just stop. All right, so we are going to dump this ordered triple into each of these equations to see if each equation comes out true. First one says take x plus y plus z, and we should get 0. So if we take 5 plus a -3 plus a -2, do we end up with 0? Does it work? Okay, so first equation works. Dumping it in the second one, we'd have 5 plus 2 times -3 minus 3 times -2, and we're supposed to get a 5. Well, here we get -6, and here we get +6. Does that add up to 5? Okay, so it works in the second one. Plugging it into the third one, we'd have 3 times 5 plus 4 times -3 plus 2 times -2, and we're supposed to get a -1. Simplifying, we have 15 minus 12 minus 4. Is that -1? All right, so if it works in all 3 equations, then we say yes, it is a solution. Okay, so the first couple questions from your homework will be just doing that. Verify, is this a solution or not? All right, so to solve a system of 3 variables, our goal is going to be to get this down to a 2-variable, 2-equation system, because you guys know how to solve those. Okay, so our first step, we're going to take 2 equations at a time, and we're going to get rid of one of our variables. I'm going to go ahead through all the steps, and then I'll pause the recording so you can write them down. Second step would be to solve that system of 2 variables, 2 equations. Then we'll solve for the variable that we eliminated originally, that third variable, and then we will check our solution. So I'll pause the recording, go ahead and write those down. All right, a couple things about this first step. It says to take two equations at a time and get rid of a variable. We're going to use that addition multiplication idea that we've been using the last few days. The key here is you have to use all three equations at some point, but you're combining them in pairs. So I might choose to use equations 1 and 2, and then I somehow have to use 3 next. I can pair 3 with either 1 or 2, but I have to get it used. Okay. The other thing to keep in mind is that you want to eliminate the same variable all the way through, because you're trying to get this down to 2 variables remaining and just 2 equations. Okay. What you would be looking for is a single variable, like a single x, a single y, or a single z. Oftentimes you have several of those, all right, which means there's no one right process that you have to go through to solve this. You might choose to get rid of x's, somebody else might choose to get rid of y's. It's going to look different, but your final answers will come out the same. Okay, so looking at our first example, I do see a single x right there, and I have some single z's there and there. Because of that, I would not try to get rid of y. Okay, that one seems more difficult. The single x's are going to be nicer because we can get opposite coefficients where they add up to 0. Okay, so we basically have to pick, do we want to get rid of x's or do we want to get rid of y's? Sorry, z's. When I look at this, I would pick the z's, because what's going to happen if I add equations 1 and 2 together? The z's are going to go away, right? That's a pretty easy one. I've already gotten one of my variables out of 2 of the equations. Okay, so the other thing I'm going to ask you to do is make sure that you write down what process you're using. What equations are you trying to put together? Are you multiplying one or more of them by something? What is it that you're trying to do? Because if you bring me a sheet of paper that has a whole bunch of this work shown on here, and you go, I'm getting the wrong answer, where did I go wrong? I'm not going to be able to tell you unless you tell me what you were trying to do, because all of you might go at it a different route. Okay? So, how I would notate this. We've listed this as equation 1, equation 2, and equation 3. I would simply say, I'm going to take equation 1 and I'm going to add it to equation 2. Okay? That's going to tell me what it is you're trying to do. And you will have to give the same kind of notation when we move into our next chapter as well. So get used to it. All right, so my equations are x plus 4y minus z equals 20, and 3x plus 2y plus z equals 8. I'm going to combine those two equations. And when I add them together, my z's go away. I end up with 4x's plus 6y's equaling 28. Okay. I'm going to circle that because I'm going to need that equation in a few minutes. Okay. Now, I used equations 1 and 2. So in this next piece, I have to pick up equation 3. I can pair it with either of the other ones, but I have to include a 3. So let's say we use equation 1 again. I want to combine it with equation 3. But if I just add those two equations the way they are, will z's drop out? No. So I do have to use some multiplication. What would I need to multiply by? The first equation by 2. So I'm going to indicate that here. I'm going to take 2 times equation 1, and then I'm going to add equation 3 to it. Okay? So 2 times my first equation would get me 2x plus 8y minus 2z equals 40. I'm going to pair it with the third equation, 2x minus 3y plus 2z equals negative 16. And what do I end up with when I add those two together? (4x plus 5y equals 24. Okay. Now, I'm going to put together those two equations that I just circled, and that's going to become my new system. It is now 2 equations that have the same 2 variables left over. Yes? You guys know how to do this. So this is that next step. We're going to put these two together. 4x plus 6y equals 28. 4x plus 5y equals 24. Can I just add them the way they are? Will a variable drop out if I just add them the way they are? No. What would I need to do? One of them needs to have a negative, right? The 4 needs to be a -4 on one of them. Doesn't matter which one. Let's say we put it in the bottom one. Okay, I multiplied through by a -1. Now what do I get when I add these up? I get 1y equaling 4. I've already got the first part of my answer. Okay? When you have a system of two variables and two equations, as soon as you find one, you can dump it back in and get the other one, correct? Okay, so dumping it back in here, we have 4x plus 24 equals 28. So 4x would be 4, x would have to be a 1. I now know that y equals 4 and x has to equal 1. The only thing I have left to do is find z. To do that, we're going to substitute these two values in, but we're going to have to go back to one of my original equations because I need all three variables again. Okay? It doesn't matter which one you pick. If this was a test question, once I figure out my x, y, and z, I would check it in the other two equations anyway. For our purposes, we're just going to try it in one. So let's say we use the top equation. Okay? We have x plus 4y minus z is supposed to equal 20. Okay? So let's dump in what we have. We know that y is 4 and x is 1. So 1 plus 4 times 4 would be 16. Minus z equals 20. Okay, so we have 17 minus z equals 20. Then what? If I subtract the 17, I have negative z equaling 3, which means z would then have to equal negative 3. I have all three variables solved. I do have to put them in order, right? So we do x, then y, then z. So my answer would be 1, 4, negative 3 as an ordered triple. Okay? All right. We're going to try 2 more of those and then give you some time to practice. All right, so again, we've identified equations 1, 2, and 3. Do we have a single x somewhere? Just a 1x? Yes. Do we have a 1y somewhere, or a negative 1y? Yes. Do we have a negative or positive 1z? So that means we could eliminate any of the three variables. We just have to pick one. Okay? So we could eliminate x. Talking through what that would require, we'd have to times the second equation by a negative 6 to put it with equation 1. And we'd have to times it by a negative 3 to put it with equation 3. Yes? Is that doable? Yes. Looking at our y's, what do you notice? We have two equations that already have both of them being 3y's. So we could get rid of the y's simply by multiplying one of those equations by a negative 1 and adding. Okay? Does that seem easier than getting rid of the x's? Maybe a little bit. Question? No, because you have to put them in groups of 2. So a negative 6, are you trying to get rid of the y's or the? You can't add them all. Because adding them all, even if it gets rid of one variable, you now just have one equation, but still two variables. All right, we have to, if we're going to have two unknowns, we have to have two separate equations. Okay, so you always want to put them in pairs. So let's say we get rid of the y's. Okay, I mark that because I have to remember after I get through a few steps here what was the variable I was trying to get rid of. So we're going to get rid of the y's first. The top equation would have to get multiplied by what? A 3. So I'm going to take 3 times equation 1, and I'm going to add it to equation 2. Does that work? Would that get rid of y's? All right. Multiplying the first one by 3. We get 18x minus 3y plus 9z equals negative 45. Pairing it with equation 2. What do we get when we add those two together? (19x) plus 8z equals negative 35. Did we eliminate y? Okay. I'm going to circle this because, again, I'm going to need it in a few minutes. Okay. Let's go back. Now we need to somehow use equation 3. Could we pair equation 2 and 3 together? They both involve a 3y, yes? So could I do equation 2 and equation 3 with one of them being multiplied by a negative? So I'll multiply this equation 2 by a negative. So my second equation becomes negative x minus 3y plus z equals negative 10. Pairing it with the third equation, what do we end up with? (2x minus 3z equals 4). Looking at my two equations now that I've circled, do they both have the same variables left over? Yes? Okay. So let's put that together as a system. Let's use 19x plus 8z equals negative 35 and 2x minus 3z equals 4. That's my new system. 2 variables, 2 equations. We're going to solve it the way you've been solving them for the last few days. We can choose to either get rid of the x's or the z's. I don't care. In this case, getting rid of z's might be a little easier because we already have opposite signs. We just need to get the numbers to match. So let's times this top one by 3 and the bottom one by 8. Will that work? Our z's will turn into 24 and negative 24? Okay. Timesing by 3. 19 times 3 is 57. We end up with 24 z's, and 3 times negative 35 is negative 105. 8 times 2x would be 16. 8 times negative 3z is negative 24z, and 8 times 4 is 32. Adding those up, we have 73x equaling negative 73, which means x has to be negative 1. Now, I need to plug that x in to one of my equations that just has the 2 variables. I can choose to plug it back in to one of these, or I can go back to the smaller numbered version. Okay? I'm going to pick to put it back in right here. Okay? That one seems the easiest. I can solve now for z. So negative 1 times 2 minus 3z has to equal 4. If I add the 2 to the other side, I have negative 3z equals 6. So z is going to have to be negative 2. So now we know 2 of our answers. We're missing the y piece. All we have to do is dump these back into one of our original equations. Which one do you want to use? We're trying to find y, right? Which equation looks easiest if we want to find y? First one? So 6x minus y plus 3z equals negative 15. All right, let's dump in what we have. X is negative 1, so this becomes negative 6. We don't know y yet. Z is negative 2, which makes that a negative 6 as well. We have negative 12 minus y equals negative 15. Adding the 12 over, we get negative 3. So y has to equal positive 3. All right, so my solution would be what? Negative 1, 3, and negative 2? Okay, I'm going to pause the recording. I want you guys at your groups to look at the next one and pick which variable you want to get rid of. We're going to go through this one and eliminate x. To do that, I'm going to use that first equation. I'm going to take equation 1. I'm going to add it with equation 2, but to get those x's to drop out, I have to multiply the first one by negative 2. Okay? So we end up with negative 2x plus 4y minus 6z equals negative 44. Combining it with our second one, we should end up with y minus 7z equals negative 39. Okay, that's my first one. Now I'm going to use equation 1 again. This time, though, I'm going to multiply it by negative 3 so that I can add it with equation 3. Okay? Timesing the first one by negative 3. We've got negative 3x plus 6y minus 9z equals negative 66. Adding it to our equation 3. We end up with 7y minus 14z equals negative 98. Okay? Now I want to take these two equations and put them together as a system. If I add them the way they are, neither variable will drop out. Okay? I'm going to need to change one of them somehow. Do you want to get rid of y's or z's? Y's we have to multiply by a negative 7 to the top one. Z's we would have to multiply by a negative 2. What's easier? Negative 2? All right, let's get rid of the z's. I'm going to take this top equation here and multiply it by negative 2. We get negative 2y plus 14z equals a positive 78. Combining, we end up with 5y equaling negative 20. So y was going to be negative 4. Okay? Then I'm going to dump that back in. I can dump it into either equation. Let's put it in right there. So we have negative 4 minus 7z equals negative 39. Adding the 4 over, I get negative 35. And dividing, I end up with positive 5. Now I'm going to take both of these answers and dump them back into one of my original equations. So let's pick the top one. X minus 2y plus 3z equals 22. Substituting y is negative 4, that makes this a positive 8. Substituting a 5 in here gets me 15. 8 and 15 is 23, so x would have to be -1. Your solution should be written as an ordered triple. Okay? So your homework, you are going to do page 813, questions 3 through 10. The first two questions, you are just verifying if the answer they give you works. All right, so questions 5 through 10 are the solving the system like we just did. Okay?